Hello, 8th graders. Here in lesson 5, we're going to be looking at negative exponents using powers of 10. And we have this image right here with an exponent of -1. And you can see that having an exponent of -1 seems to flip the image. That might not make a lot of sense right now, but by the end of the lesson, it should. Here we go. Okay, this first one here wants you to solve each equation mentally. That means figure out what x needs to be to make both sides the same. Let's do this first one together. 100 over 1 is the same as 100, and that would need to be equal to 10 to the second to make that equal, to make both sides equal. Go ahead and try the rest and start again when you're ready. Okay, after this side here, these are what your x values would end up equaling for each of these, and this is what each equation would end up looking like. And you should start to see a pattern here. Notice our exponents are going down by 1, and notice how the denominator is changing, which changes the entire fraction on each of these. You'll be seeing a similar pattern as we keep going. Okay, to start out here, we're going to fill in this entire table. I'll fill in a couple squares, and then you guys are going to work on filling in the rest. We'll start right here, writing it as a decimal. 10 squared as a decimal would be 100. We're going to write it as 100.0. You can see that they all have a 0.0 on them. Then we'll go to right here, writing this as a fraction. This would be 1,000 over 1. Right here, this one is going to be 10 to the 0 power, because if you notice, as we go to the left, this means that we're multiplying by 10 each time. Okay, do your best to fill in the rest of the table and then start again when you're ready. Okay, here's most of the rest of the table filled in purple here. And the big idea is to start to see patterns with what's happening. I want to focus on this column right here. To get 1 after multiplying by 10, we would need to start with 1/10. Here it is as a fraction. And then writing it with an exponent, if we keep following our pattern, notice how the exponent is increasing by 1 each time. And so to get to 0, after increasing by 1, my exponent would need to be 10 to the -1. And if I keep going with that pattern, there would be my other 3 parts to the table. So if you'll notice, like our 10 to the -2nd, that is the same as 1 over 100, or as a decimal, 1.01. So number 1 says, as you move toward the left, each number is being multiplied by 10. We can see that up here on the top. So what is the multiplier as you move to the right? Well, as we move to the right, we are multiplying by 1/10. Number 2, how does each of these multipliers affect the placement of the decimal? Well, in the decimal places, you can see just keep moving by 1, either to the right or to the left, depending on which direction in the table you're moving. Okay, same table we were just using, but let's go on and start with number 3. Use the patterns you found in the table to write 10 to the -7th as a fraction. So I want us to focus on this last column of the table with 10 to the -3rd. I like to say that the negative exponent kicks it to the denominator, and another way to write this would be 1 over 10 to the +3rd, which is 1 over 1,000, which you see there in the table. And so 10 to the -7th, I could write as 1 over 10 to the 7th, which would be 1 over 1 with 7 zeros. And there you go. Number 4, use the patterns you found in the table to write 10 to the -5th as a decimal. For the decimals, let's look up here again at the 10 to the -3rd. Really, the decimal moved to the left 3 spots because of that -3 exponent. And so 10 to the -5th, I could rewrite with like this. I could start with 1, and then I'm going to move the decimal to the left 5 times, and then I'd fill in all those spots with zeros, and there's what I'm left with. Number 5, write 1 over 100 million using a single exponent. Well, that could be 1 over 10 to the, that's going to be 8th power, because there's 8 zeros, which is the same as 10 to the -8 power. again, that negative exponent kicks it to the denominator. And number 6 is kind of the most important one, figuring out our rule. Use the patterns in the table to write 10 to the negative n as a fraction. Again, it kicks it to the denominator, so they'll be same as 1 over 10 to the positive n power. Okay, in our next activity, we're going to use our exponent rules to match some things up. I have numbered the left-hand column and lettered the right-hand column just to make things a little bit easier. I'm going to do one of these with you guys, and then you're going to try them on your own. The one we're going to do together is number 2. So if we're looking at this, I see 10 squared. So I'm looking for something where I have 10 times 10, and then being taken to the negative third power, which is going to kick that 10 squared to the denominator. And so that's actually going to match with our first one here. If you'll notice in the denominator, we see 10 squared, and it's in the denominator being multiplied by itself 3 times. And so there's that negative 3 power. So go ahead and try matching the rest of them and start again when you're ready. Okay, so here's how they would match up. Number 1 goes with D. That one is kind of a review from stuff we talked about. Number 3 goes with B, and that's because 10 to the negative 2 power, well, that's the same as 1 over 10 squared, or 1/10 times 1/10. And you notice we're doing that 3 times there. And number 4, this is a really goofy looking thing where you don't usually have fractions within fractions, but 10 to the negative 2 power, here that is, with the 10s being kicked to the denominator, and then all to the negative third power, so then that whole thing gets kicked to the denominator here, and then there's 3 of them. Now B, write 10 squared to the negative 3 power is a power of 10 with a single exponent. Using your exponent rules, remember we can multiply those exponents, and that would be 10 to the negative 6th. Okay, here we are using our exponent rules with division. Again, I've numbered and lettered them, and the one we are going to look at here is, again, number 2. So I'm looking for something where I have 10 squared being divided by 10 to the negative 5th. So that negative 5th power is going to kick that part to the denominator, but my numerator isn't, and so that's going to match with D. Go ahead and try those on your own, and also try B, and start again when you're ready. Okay, this is how the rest of them match up. Number 1 goes with B. That is a pretty basic one. We've seen that before. Number 3, 10 to the negative 2nd. That's this right here, where your 10 is in the denominator, and then your 10 to the 5th is just kind of normal right here, so that matches with C. And then number 4, both of these have negative exponents, and so both parts are going to be written as fractions. And then going over to B, using our exponent rules, remember we subtract the exponents, and so this would be the same as 10 to the power of negative 2 minus negative 5, because I'm subtracting my exponents. Negative 2 minus negative 5. And when I do that, that's the same as adding 5, and so this is the same as 10 to the 3rd power. Okay, in number 3, this is how they would match up. This one's probably a little bit easier than the other ones we looked at. Just remember that when you see that negative exponent piece, that's where you're going to see them written as a fraction. And then B, remember when we are multiplying with exponents, or when we're multiplying, we can add our exponents. And so this would be the same as 10 to the negative 4th plus 3 exponent, and negative 4 plus 3 is negative 1. And there we go. Okay, on this slide, I just want you to take some notes. We're just going to talk about this 4th bullet point right here. Think about the meaning of exponents. How is 10 to the 3rd related to 10 to the negative 3rd? And we will see that they are reciprocals of each other, because 10 to the 3rd is 1,000. And 10 to the negative 3rd, I could write that as 1 over 10 to the 3rd, which is 1 over 1,000. And 1,000 and 1 over 1,000 are reciprocals of each other.